Once we have decided on the sampling approach, the next query in the mind is how much to sample. In most of the practical scenarios, we see a lot of variation in the population data from where the sampling has to be done. And the question that troubles the most is what should be the sample size which can represent the population parameters. Beginners at time would have a genuine doubt that how can a sample that is a part of the population represent the characteristics of the population? How is it possible? Now these are questions that must be answered. To understand how a proper sample represents the population characteristics, first let's understand why we can't pick any data point and call it a sample. Why the sampling has to follow a specific scientific method, which in turn ensures that the sample will end up reflecting what the population data has to tell. Let's say we are dealing with a population of balls, each weighing 5 grams, and we have to draw a sample to estimate the average weight of a ball. In this case, whether we take a sample size of 1 or 2 or more, average is always going to be 5 grams. We can draw the sample or pick a sample from any position. Still, the average would be 5 grams. Always, isn't it? To understand its relevance, let's look at a new population of the balls. Difference is this time each ball has a different weight. Here, if we draw a sample size of 1, average is equal to the weight of that ball and not equal to the population average. Same is the case with sample size 2. We may get a little closer to population mean, but still it's not equal to the population mean. In case 1, but a similar sampling was making the sampling mean equal to population mean. What is bringing in this difference between case 1 and case 2 is the variation that is there in the ball weights in case 2. Because in this case, each ball has got a different weight. So first thing to remember is that variation is the main culprit. Otherwise, sampling would have been very simple. We could have drawn from anywhere and how much ever we desire. But we don't live in an ideal world. Variation is everywhere. So we need to learn to deal with it. Stats gives us the concept of variance or standard deviation to quantify the variation. It can be in simple understood as the average spread of data from the mean or center of data distribution. The earlier video about understanding the sigma level has a detailed explanation of standard deviation. You can find the video link in the description, or you can look for the video on the page. But for the sake of this concept, let's go through the calculation quickly. In the table on the slide, we have recorded the weight of the balls that we saw in the second case on the previous slide. Now we take a difference of each data point from the mean, which is 5.5 in this case, because that's how we can estimate the spread of the data. To neutralize the effect of negative values, we take a square. Then we sum up the squared values. Since we want the average spread, we divide the sum by n minus 1, where n is the number of data points and n minus 1 is the degrees of freedom. These concepts have been detailed in the previous video on sigma level. Finally, we take a square root to find the standard deviation, because standard deviation is the square root of variance. So for this data set, we get a mean of 5.5 grams and a standard deviation of 2.4. This standard deviation plays a very important role in determining the sample size.